All right, let's check and see how you did on this assignment that pulls everything together, finding percents and probabilities, but also z-scores and context and maybe even the mean and standard deviation. Can you do it all? All right, let's see. So these first two problems were very interesting because they just said find a z-score. And I'm like, okay. Um, So instead of, even though it told me that the x is normally distributed with a mean of 30 and a standard deviation of 4, it says find the z-score. And so I don't know why it gave me this extra information here. All right, so we had the top 15%, so we inverse normed the bottom 85%. And there's your z-score for B, negative 0.67. And then, of course, for the middle 20%, we have 80% left between the outside edges, each containing 40%. So this inverse norm of 0.40 is negative 0.25, and then I know the other one is the positive version. All right, now we get into the context values and the context numbers and such. So this one, oh, it says what's the probability, okay? So that means we are going to be doing the norm CDF stuff that we had done 2 days ago. So here was all the information. So it ended up giving me these first 3 values. And so then I knew I needed to get my z-score. So I did my z-score formula. I then wanted to travel more than 100 kilometers. So that meant I norm CDF'd above. All right, next. We're going between 50 and 70. So I knew then, based on that, I had 2 x values. So from those 2 x values, then, of course, one of them is a z-score of 0 because it's the mean. And then the other was 1.33. I then norm CDF'd between those two to get that probability, percent, proportion of observations, use norm CDF. All right, here we go. So now this one is unknown x values. Okay, so then that means I got to get my z-score some other way, some other information. Well, look, at least 70%. That means I want 70% or higher. Okay, so he wants to be in this location here so that he is above 70% of the data. So that's why I inverse normed 0.70. So that put my z-score at 0.52. I then solved and see he needs 552 on that national test. All right, here we go. Okay, so this one, look, I just kind of like noticed that this here was 1 standard deviation down and then 1 standard deviation up. So I just didn't even do the 2 z-scores and find it. I just did 68%. Okay. Same thing here. I noticed it was 2 standard deviations down and 2 standard deviations up. So I just said 95%. Okay. You can do that. Alrighty then. So here we want to know what score. So we want to know the context value, the x value, to be in the top 10%. So top 10% means you are above 90% of people. So that's a z-score of 1.28. Set it up, and you need to have an 83 to be in the top 10%. Okay, bottom 25th. So that is the area below. So I inverse normed 0.25 to get this negative 0.65 z-score and then solved. Oh, and middle. So I know I've got 2 parts. It looks like part B, I saw, the 25th percentile was negative 0.67. And so the top was positive 0.67. So I knew from part B that the lower bound was 63, upper bound 77. So that middle 50% of scores is between 63 and 77. All right, so here we go. Gosh, I really think this is kind of debatable here. It says, what interval would you expect most people's body temperatures to be? So, what does that mean? Like majority? So, we're saying over 50%. Um, so, I interpreted it as, and I don't think you would be asked to have something ambiguous such as this. If that's the case, if most was open to interpretation, then on AP, you would just explain what your interpretation was, and then you would show the work for that, and you would get credit for it. Okay? So I put here, I interpreted most as being no outliers. Okay, so then therefore I chose the z-scores of -2 and +2. So with that being said, if you said I interpret most as being the middle 50%, then you say therefore have a z-score of this and that or whatever. Okay, then that's giving the criteria that you understand what people are talking about. You just have a different interpretation of this ambiguous word that isn't clarified as most. All right, so you can see how I did that. Got the interpreted the z-scores as -2 and +2. All right, what fraction then would be? Oh, what fraction? Also, proportion of observations and percent of people. So that's my norm CDF. So I guess I had gotten a z-score. Huh. Oh, here we go. I showed my work over here. I was like, where is all my work? Okay. So see here, here's my z-score formula. Don't forget you need to show z equals your x minus mean over standard deviation. Okay. And then the coolest 20%, the coolest, not the coolest cats, but all you cool cats and kittens. So inverse norm of 0.2, -0.84. So then that's the z-score I used and your answer. All right, moving on. So here you can see that for all of these things, I clearly wrote what I had, what my z-score was, and then what that x value solved to be. So I'm not going to go over these detail by detail. I'm just going to let you look and check what data I had. Middle 80%, that puts 80% in the middle, so 20% left puts 10% on each outside edge. So inverse norm of the 0.10, -1.28, and +1.28. That would be my lower values and my upper values to solve for. All right, and then here we go. Oh, this is such an interesting problem because it is true. Um, these are true standards, and it's interesting to see what they'll actually fund. And there's a discrepancy between what they classify as mentally retarded and what they fund. So very interesting here. So here we have, see, look, here is my work. Here is my z-score. So my z-score is -1.25. I then consider 10.56% of the U.S. to have IQs below 80. So a little, almost 10.5% of the nation are actually classified as mentally retarded. It's interesting, very interesting. And you know that with schools, so the average yearly percentages that you must have, like the federal guidelines, give schools values of how much percent of their population they will allow to be in, say, special education. And guess what, people? It is they allow 5% or something. So obviously, if this is the case, then then we're going to have a higher proportion of mentally we're going to get marked down because we have truly 10%, 10.5% mentally retarded, and yet we're only allowed to have 5% in the special ed program, or else you get marked off. So what's happening there? Where is that disjoint? That happens here with the budget. Look, the people who have an IQ of 72 or below are going to get funded. So only the bottom 4%. So look, there's the people from an IQ of 72 to 80 that are mentally retarded, that are considered class classified as that who are not getting funded. All right. And then here were these ones that was kind of ambiguous. What is this? What are these values here? So here the X and the mean and the Z-score was that bottom 25%. Okay, so inverse norm of 0.25. Here, 12% is above. So that is the top 12%. So if you have that top 12%, then you have 88% below. That's why my Z-score came from inverse norm of 0.88. And there's my X, mean, and standard deviation. Then you do algebra to solve. Next, let's see, 90% of the data is above. So again, that's, 90% of the data is on the top part. Oh, looky here. That means there's only 10% on the bottom. So that's inverse norm of 0.10. 185 was your X, and so on. And then 3% below that X value of 202. So there you go. And this is the very interesting problem. I love it. Let's see how you did on this little bonus problem. We're actually going to get into this on the lesson today. So if you did not get this, then you can stop the video here. I'm going to teach this in today's lesson, but it's just very interesting. I'm curious to see how you did. There's a few different ways to solve this because what happens is since you have two unknowns, the mean and standard deviation are both unknown, then you get a system of equations. So two equations occur essentially is kind of what's happening. And so then you know that there's three different ways to solve a system of equations: substitution, elimination method, or graphing. So there really is a few ways that you could do this problem. But here is one way that makes sense to me, the one I have thought that is a concrete visualization of what's happening. So here we go. So the 5% have learned to walk by age 10. So that's only 5%. That's the bottom 5%. So look at this red line here. That's inverse norm of 0.05. So I have got two things happening here. So I've got z-scores. Oops, let me get something to write with. So I've got z-scores right here on top, and then I've got x values underneath. Okay, so my z-score for that bottom 5% is negative 1.64. All right, and that corresponds to an x value of 10. All right, next, my inverse norm of 0.75. So it says 75% are walking by age 13. So that means the 75% and below. So that is a inverse norm of 0.75. That's a 0.67. So that's their z-score there. And that corresponds to an x value of 13. So there's the z-scores and there's the context values. Well, these are in the same location. So if they are in the same location, then these distances are equivalent. So from negative 1.64 to positive 0.67, I'm going to do the subtraction. 0.67 minus 1.64, and that's a total. So this distance from one line to the other is 2.31 standard deviations. Remember, that's what a z-score says, is how many standard deviations. Z-score is a measure of the standard deviations. So this distance is 2.31 standard deviations wide. So that's what I wrote, 2.31 SD. I just used SD. And the reason is because if I use sigma, sometimes people think that looks like a zero, and then things get confusing. So I use SD to represent standard deviation. And see, and if I just put S, then sometimes that looks like a 5. And so I usually do SD for standard deviation. All right, here we go. Now, the distance, of course, in X values, 13 minus 10 is 3 months. Okay, so 2.31 standard deviations equals 3 months. And I solve, and that means a standard deviation is 1.3 months wide. Those are months. Okay? So there is my standard deviation. And so with your substitution, with your systems of equations, once you find one of the variables, now go back to one of the equations and solve for the other missing item. So just pick one of these locations. You have an x, you have a z, you have a standard deviation. So now you have three things that you can set up in your z-score formula and solve for the mean. And there you have a mean of 12.13. And again, I should have put context in here. That's the months, okay? So average of 12.13 months with a standard deviation of 1.3 months. All right, there was your bonus question. Also, what we're going to learn today. So that kind of gets you started on today's assignment. Hope that helped you. Hope you're doing well and you don't have many questions on that. If you do, then just email me or message me and sign up for a time that I can help you.